السلام عليكم محمد.
وعليكم السلام.
Just 1 or 2 minutes and we start. Okay.
Hello, everybody.
Hello, how are you doing?
Good. How are you?
Oh, fine, thank you, Professor Halim. Good to have you with us.
Sure, I'll be following.
Yeah, good.
Hello.
Hello.
Hey, Antonius.
Okay, good afternoon, everyone. So thank you for joining us for our last Wednesday lecture for the year 2020. So thank you for spending at least the next hour to talk about our SharjahSat-1 CubeSat that we have in collaboration with Istanbul Technical University. So Engineer Mohammed Salah is going to brief us about the latest point that we arrived for the completion of this CubeSat, and hopefully, so at the end you can ask him questions about the satellite, what does it do, and also when will be the launch date. So hopefully it will be very informative for all of you, and hopefully you will benefit from it. Please, Mohammed, take.
Thank you, Doctor. First of all, can you see my screen and can you hear me clearly?
Can you try?
Sorry, you can?
Yes.
Okay, so welcome to our bi-weekly lecture here at SAASST.
We are not hearing you, Mohammed.
You can't hear me?
صوتي قطع.
Okay, let me switch the headphones. Just a second. Hello, what about now? Is it better or worse?
Yes, perfect.
It's better.
Same, we are not hearing you, Mohammed.
Same thing?
Yeah, there is no audio.
What about now?
Not yet, no.
We can hear you, by the way.
احنا مش سامع.
Sorry about that. Can you hear me?
I can hear you.
Everything is clear, it's not cutting off. Okay, we can hear you, we can. Okay, then I'll start. And if there is anything, please let me know. So, welcome to the bi-weekly lecture here at SAASST. I am Mohammed bin Ashur from the research assistant at the CubeSat laboratory. Today, I'll give you an overview about CubeSats, educational satellites, and then going into our lab, our CubeSat lab, and then further to the latest updates in the SharjahSat-1 project. So this is the outline. I hope it will be good for everyone. Everyone will benefit from it. Starting with the satellites, educational satellites, what are CubeSats, and the university, why the universities launched these CubeSats to space. And then to CubeSat laboratory, what do we do, what do we have? And finally, SharjahSat-1, the objectives, latest updates, and the workshops and courses that we have regarding this project. And finally, summarizing. So why do we go to space? Why do we spend all this money? There are four main reasons. Scientific, you want to study what's out there in the solar system. It can be for exploration, and it can also be for military purposes and real-life applications such as communication or Earth observation, etc. So whenever we talk about space missions, these five points are very important. So we have the spacecraft payload, which is the instrument that will achieve the objective of this mission. And then you have the spacecraft bus, which will help this payload, the payload to achieve the objective. And then you have the launcher, which will place your spacecraft into the required orbit. And then you have the orbit, which will be the path for your spacecraft while it's operating, and the ground system for communication and control. Here are some different types of spacecrafts from flybys, which have an escape trajectory, like Voyager, for example. You have orbiters, atmospheric spacecrafts, observatory like James Webb, which will be launched next year, and maybe Hubble telescope, penetrators, rovers, landers, etc. So we have all these things.
Mohammed, if you can change this, the headphones, or because the voice is like cutting, so there's something wrong with the speakers. If you can just go directly without using them, if possible. Sorry for that.
No problem. What about now? Is it still cutting?
No, excellent. Now it's excellent.
Now it's excellent. Can you hear like an echo or something, or it's fine?
It's fine.
Okay. So I'll hopefully it will stay like this. As we've seen here, there are different spacecraft types. Now our focus here is about satellites. So there are different extremes to these satellites, as you can see here. You can go to the large satellites, which are more than 1,000 kilograms, such as communication satellites, which orbit in the geostationary orbit. And on the other extreme, where universities are mainly interested, you have the nano, pico, and femto satellites. Of course, now as you go smaller, the price decreases. As you go larger, the price goes up, and you'll need a larger team. The project will be more complex, and you will require as you pay more, you're paying more, you won't accept a very high risk. So this will be a challenge, and not everyone can afford such big missions. But on the other side, if we're looking at the smaller satellites, the price will decrease. So when you have a low cost, you can accept more risk, which will result in a shorter development time, which is really good for universities. Moving on, looking at educational satellites, if we can see here in this picture, I believe this one is SAASST-1. It is a British amateur satellite. It was launched by University of Surrey in 1981. And this is also by Technical University of Berlin, CubeSat, I believe CubeSat A. It was launched in the 90s also. Now, universities did have the interest, but it was very hard to launch these satellites. Students eventually come up with these complex designs, and they go over budget. Fewer launch availability, and not so many universities are involved in these projects. It was also hard for students and professors, especially that if you're working on this big project, so let's say if it takes more than the years that you'll spend in the university, so it's a problem. Even the research papers are limited compared to other projects that you have. So what happened after that? In 1999, Professor Bob Twiggs from Stanford University and Professor Jordi Pegswari from Cal Poly came up with this idea of making it easier, making these satellites easier, and in a shorter development time, you can come up with these small satellites. What's the reason for them to have this shape is to have a better access to space. They're low cost, so you don't need this every space grade component. And they created like a standard for these satellites. They wanted this to be a university project. So, for example, if you have a master's student, he can design and develop and launch his satellite. And of course, they wanted the industry to be involved for more funding. So they came up with this. CubeSats are these small satellites in a cube shape with a standard dimension of 10 by 10 by 10 centimeters. However, these things then evolved, and then they came up with different variations for the size to 2U, 3U, 6U, and 12U, going on, depending on what you require in this mission. And typically weighing less than 1.33 kilogram per U, which puts some limits. So even if you try, it's very hard to get that complex within that shape and that size. One of the main advantages that they had is the deployment mechanism, which is the P-pod. It was a really successful idea because it was a safety option for even the launcher or the launch operator was more relaxed when it comes to CubeSat, especially that they'll be in this box. So nothing will affect the rocket or any other payload in this rocket. And of course, nowadays, the applications vary from Earth observation, communication as constellations, or scientific objectives, technology demonstrator, and interplanetary missions. Of course, launching them to space is one of the keys that drove these CubeSats. As you can see here on the left, this here you have a very big payload, which is the main satellite in this rocket. And down here you have the small P-pod, 3U CubeSat P-pod. So they are secondary payloads and they don't affect the main payload. And this one here is the Indian rocket in 2017. Which had 104 satellites, 103 of them were CubeSats, which was a big jump. And of course, you can launch them through the Japanese module in the International Space Station. Moving on, looking at the exponential growth of CubeSats, If we look from the beginning of CubeSats until 2012, around 100 CubeSat was launched. And then from that year, the standards became fixed and more defined. So you can see the exponential growth from that time. And by 2018, by the end of 2018, they exceed 1,000 CubeSat launched, which is a really big deal, especially when you look at the mission type here. You can see that even though everyone is getting involved in the last few years, but universities are still the main driver for these CubeSat missions. Moving on, so this is what we have for CubeSats. CubeSats are accessible for student, researchers, and commercial entities. They come in small sizes and less weight, which means less cost, which also means that you can accept a higher risk. With shorter development time, you can try your new technology, you can test it as you fly. You have this focused objective, and you can launch it as a secondary payload. Also, when it comes to space debris, it is a problem, but as long as you keep it in a naturally decaying orbit, it will come back and burn as it enters the atmosphere. So when it comes to universities, still it's not, why would they invest this much into CubeSats in specific? So the educational outcomes out of these CubeSats are really big. There are three main outcomes that I have here. First is the technical outcomes. So if I'm working on this subsystem, I'll gain the specific technical skills focusing on this subsystem. Adding to that, I'll get a general overall idea of general knowledge over the other subsystems and the whole space mission. And it will also build my character, as I have to take many decisions depending on my trade-off analysis. From the weight, I'm limited with the mass budget. From the power, I'm limited also with the power budget. I have to make sure that everything is within my limits. The size of the instruments, can they be folded or not? If I want an active or a passive controlled subsystem, depending on the accuracy and the accuracy needed for this mission. Also, you have the solar array, you have different options. So all these options that will make students take decision and compare between all the different options that they have. The other outcome will be the cross-disciplinary outcome, especially that any spacecraft, you have different subsystems, from electrical power subsystem to the ADCS, to the command and data handling, communication, thermal, and propulsion if it's in your CubeSat or if it's in your spacecraft. So it's good to have all these teams working together, so the student will be exposed to majors that or ideas or that he didn't cover in his major. If he was, for example, an electrical engineer, he'll be involved with all these subsystems, especially that their decision will affect his design, and his design will also affect their decision. And lastly, you have the professional outcome. When students graduate or during their studies, it's hard to move to the industry right away. Working on these big projects, it's not very easy. So these small missions or the educational missions, they ease this transition towards the industry, especially that you can have them throughout the academic framework. Of course, it's highly motivational for students. Instead of working on a project that will stay in the lab, rather you can work on this project, and then at the end of your studies, it will be in orbit. And also, it will identify the areas to improve, especially that it's a cross-disciplinary field. So you'll know which areas do you have to build yourself in. So after having all this introduction about CubeSats and the educational satellites, what do we have here at Sharjah Academy for Astronomy, Space Science and Technology? We have here the CubeSat Lab. So the CubeSat Lab is for research development of CubeSats and CubeSat technologies. It will also provide services to the educational institutes to accelerate the UAE's race to space. So just covering slightly the facilities that we have here in the lab. We have of course the high performance workstation loaded with all the required softwares to design and simulate the satellite in space environment, from 3D experience CATIA to a 3D model, your design or your CubeSat, to ANSYS for structural analysis, etc. Thermica for thermal analysis, STK to simulate this mission and look at your orbit and different, for example, if you want to look at the eclipse, generate different reports, and of course, electronic components and PCBs. So we also have the clean room, which is a certified ISO 6 to make sure that when we are working on this, on the CubeSat itself, it's in a safe environment away from dust with a constant temperature and humidity, where we conducted the functionality test for our components. It's also used for the assembly testing and integration for CubeSat components. Moving on, we have also the ground station, which is officially authorized by the TRA. We have the UHF, VHF antennas to communicate with the SharjahSat-1 once it's in orbit. This is actually a crucial step, especially for the future spacecraft satellite missions. And also we can control this from inside our lab remotely, which is a good thing. So this is our lab. It summarizes all the steps, which gives a better or an overall idea, because it can be in some labs it's only paper. So students work on these spacecraft designs on paper, but here you can work on it first in theory and on paper, and then you can design this mission. You can also design the subsystems and analyze and and simulate them in the space environment using the softwares provided, and of course integrate the whole system in our clean room, which shows that it's a complete lab, and we're still building this lab and expanding. So now SharjahSat-1. What is SharjahSat-1, and how did we start this project? So SharjahSat-1 is our first CubeSat mission that will be developed by SAASST. It's aiming to build the capacities and expertise for future CubeSat missions. It's a 3U CubeSat to be operated in LEO, low Earth orbit, around 550 kilometers, consisting of 2 primary payloads, the improved X-ray detector and the dual camera system. So even though it's an educational satellite, it's actually a scientific satellite. So when we look here at the scientific objectives of this CubeSat, it will observe and study the solar coronal holes and their effect on the space weather, especially that space weather when the sun is active, it has a lot of impact on satellites and on the planet itself. So it's really good to study and understand that. It will also detect the hard X-ray sources around in our universe, in our solar system. Of course, we're partnering with Istanbul Technical University and Spacecraft University. We're in close collaboration with them. This is the overview of SharjahSat-1. Of course, we'll have the payload, the improved X-ray detector for the scientific objectives, including the dual camera system. We'll have the structural subsystem, which is, as I said, it's a 3U CubeSat. You'll have the thermal subsystem for thermal management and the onboard computer and data handling, which is the main brain of the CubeSat, the OBC. You'll have also the EPS with the batteries, solar panels, etc. And the attitude determination and control subsystem, which is really important for our mission, especially that we have the IXRD that has to be pointed towards a certain direction, and then you have to point also the antennas for communication. You have to also, you can use the ADCS subsystem for the thermal management. So if a site gets overheated, you can rotate. It will have 3 reaction wheels in the 3 axes, and along with the sensors such as the star tracker and sun sensors and nadir sensors, etc. You'll have also the communication subsystem, which is using UHF, VHF, and the S-band to downlink the data from the payload. This is also another picture to look at the different subsystems and different components in the CubeSat. Moving on. So where are we now in this project? So currently, we're submitting the application for the IRU for the frequency allocation. The CDR, the critical design review, is complete. We're constantly, of course, updating the mass budget, inertia, and center of gravity constantly. We've done last month, we've done the health check for the ADCS and the analysis using the EOS software. We've also done along with the team, the algorithm flowchart for SharjahSat-1 operations. So if it goes to safe mode or critical mode, how will it get out and these things. Also the thermal analysis for the satellite, and still working on the SharjahSat-1 ground station console. And the engineering qualification model is also being assembled right now. So what's planned for the future? What's planned is to have the S-band ground station installed, to perform the qualification test, and then integrate the flight model and do also the acceptance level test for the flight model. And also along the way, we're expanding the lab, as I said. So we'll get the TVAC, the thermal vacuum chamber, and the vibration table. So hopefully we can do all the testing here in our lab. If you look here, this was in November. We were doing the ADCS health checks, making sure that everything is operating. Also making sure that the star tracker is operating, the sun sensors, everything is healthy and good to assemble. And this is, if you look here, this is the latest update for the engineering model of SharjahSat-1. Moving on. So maybe you're a student, or maybe you want to get involved, you're interested. So what do we also offer here at the CubeSat lab? These are some of the workshops that we've done even before SharjahSat-1. These were a series of workshops, a build-up to start this mission. From CanSat workshop back in January 2018, Arduino workshop, STK workshops, which is done every academic year, 6-week CubeSat course, summer internships as students are joining constantly. So it gets interesting, especially that summer internship students come from different majors, so they come up with different ideas every now and then. We also done Katia workshop, which was in November 22nd. And hopefully next week, December, I think so, yeah, December 27, we'll have the ANSYS workshop, and then after that, we'll have the Thermica workshop and STK. So in summary, the CubeSat missions provide valuable training and experience for young engineers and students. Here in our CubeSat lab, we can design and fabricate and test these CubeSats and develop these CubeSat missions. And SharjahSat-1, which is our first CubeSat, is still undergoing. We're still working on it, and hopefully You'll be with us when it's launched. This is our team, supervised by Dr. Elias, Engineer Tarifa, Engineer Ibrahim, and myself. And here are all the links for any updates. If you're interested, we keep on updating these our pages here, so it's good to come and check on us. That's a fast summary of where we are with this project, and I tried to make it brief so everyone can benefit from it. If you have any questions, anything, please.
Thank you, Mohammed. Thank you. Please, do you have any questions for Mohammed?
Oh, I do have a question. So after this mission, what kind of missions are you planning to build upon?
Okay, thank you for this. This is a really good question, actually. Actually, after this is only the start. SharjahSat-1 is only the first CubeSat. So we're looking up for many, hopefully many new CubeSat missions. I believe we have Dr. Mubashir is also currently working on the GNSS CubeSat. So hopefully it will be our second CubeSat. And also we have different ideas with the Meteorite Center. They have this idea of a meteorite capturing CubeSat, and different, honestly, different institutes or entities here in UAE. Whenever they visit, they're interested. They have different ideas. So we're looking up for future collaboration with different places. So it's good to, if you have a suggestion or an idea, please email us or get in contact.
Okay, thank you. And is there any plans of testing and commissioning the ground station before the actual satellite being launched? Are you already communicating with and receiving telemetry data from others CubeSat missions?
Yes, actually, our UHF VHF ground station is operating from 6 months, and
okay.
All in our CubeSat team in our lab, they're all licensed. So we do go every week to get to catch some satellites. So it's really interesting. We're trying to get as much experience as possible. So when we launch SharjahSat-1, we're all ready for it.
Okay, thank you.
Any more questions? So as Mohammed says, so the our SharjahSat-1, we thank Professor Alim and his team at Istanbul Technical University for all the expertise, and hopefully it won't be the last partnership. So we have several projects in the future. So we have our GNSS. We may also have another one, maybe related to observing meteors. I know that the Japanese, they do have some project in this sense. So we may duplicate that. So we'll see how things are going to move. But our SharjahSat-1 is our first shot, and we have, as we say, so we have several projects to be worked out, and hopefully things will go for the better for the CubeSat lab. And the good thing about that, we are linked to the University of Sharjah. Hopefully this coming fall, or we're going to have for 2021, we're going to have the MSc in aerospace engineering, and it will have 2 tracks, avionics and also satellites. So aerospace related to satellite technology and so on. So we'll have more graduate students working in the CubeSat lab. Okay, so thank you very much for attending this last bi-weekly lecture for 2020, and hopefully next year it will be as fruitful as 2020. So thank you very much, and see you next time. Thank you very much.
Thank you.
Thank you.
Thank you. Thank you, Mohammed.